This is a demonstration of Hypercube. I would like to begin by walking through our file tree. At the top level, we have config. Please note the ontology document. Underneath config, we have our domains. Please take note of these names. Under config, we also have overlays. Again, please take note of these names as they will come up later. Within proposals, we have written 4 proposals to test today. And finally, within source lives the Hypercube adjudicator. Within this folder, we have our adjudicator and our program, as well as our domains, authorization, resources, ID, and transition. We also have our models. Hypercube is an ontology-forward, rule-authoritative, state space adjudication engine. I am going to build a working Hypercube from scratch, demonstrating the core concepts. Those core concepts are ontology declaration, domain partitioning, frame overlays, and the macro pull micro filter adjudication process. What you will see is not a simulation or a game engine, nor is it a behavior tree. It is a system that decides what is allowed to happen based on explicitly declared rules. If something happens in a Hypercube governed system, it happens because the ontology permitted it, and for no other reason. Every Hypercube begins with an ontology. This is the declared reality. What exists, what properties things can have, and what states are valid, as well as what transitions are possible. I am building a task execution system. This could be a game handling quest permissions, a robot deciding if an operation is safe, or a workflow engine managing job authorization. The pattern is universal. We begin with 3 entity types. Agents, actors that propose actions. They have roles, clearance levels, and resource pools. Think of the agents as characters in this context. Next, we have tasks, units of work. They have required clearance, resource costs, and status. Finally, we have resources, or consumable assets, time, energy, materials, or currency. Below that, we declare valid states. An agent's role can be operator, supervisor, or administrator. Clearance runs 1 through 5. Task status flows from pending through authorized or denied to executing to complete. Then we declare valid transitions. A task can go from pending to authorized, but never from complete back to pending. These transitions are the only ones possible. If it is not declared here, it cannot happen. Finally, invariance. An agent cannot execute a task above their clearance. A task cannot be authorized if resources are inefficient. A denied task must include an explicit reason. These are laws, not suggestions. This ontology is now our ground truth. Everything else we build references this. If we change this ontology, we change reality. If we do not change this ontology, reality does not change. And that is the crux of ontology forward design. Now we partition this ontology into domains. A domain is a bounded rule space governing one axis of meaning. Domains are orthogonal. They don't bleed assumptions into each other. The first domain is authorization. This domain governs who is permitted to act. Rule auth 001. Agent clearance level must meet or exceed task required clearance. If the agent does not meet or exceed task required clearance, denial. The denial message is explicit. Insufficient clearance, agent has X, task requires Y. Rule auth 002. Agent role must be in the task's allowed roles, if specified. Denial message explains exactly what role was needed. Rule auth 003. Agent must not be in cooldown for this task type. Again, explicit denial with remaining cooltime. Please note, these rules do not know about resources. They do not know about state transitions. Authorization only cares about permission to act. That is domain isolation. Second domain, resources. This governs what assets exist and can be consumed. Rule RES 001. Resource cost must not exceed agent's available resources. Explicit denial with required versus available. Rule RES 002. Resources cannot be double booked. If another agent has reserved it, it is a denial. Rule RES 003. Resource consumption is atomic. All or nothing. There are no partial allocations. Please note, resources does not know about clearance levels. It does not know about role permissions. It only knows about asset availability. If authorization approves, but resources denies, the proposal fails. Both must pass. The third domain is transitions. This governs What state changes are valid? Rule trans 001. Status changes must follow the valid transition graph. Pending can become authorized or denied. Authorized can become executing. Executing can become complete. Anything else is denied. Rule trans 002. Executing tasks cannot be reauthorized. You cannot change the rules mid-execution. Rule trans 003. Complete tasks are immutable. Done is done. 3 domains. 3 orthogonal axes. Authorization asks, may you? Resources asks, can you afford it? Transitions asks, is this change valid? A proposal must satisfy all 3. Now we adjudicate. I am going to submit a proposal and walk through the macro pull micro filter process. Test 1. Baseline authorization. Proposal. Agent Alpha with clearance level 3 with 50 energy in their resource pool requests task Delta, which requires clearance 2 and costs 10 energy. The task is currently pending and we are proposing to authorize it. Macro pull phase. The system gathers relevant state. Authorization domain implicated. Agent clearance is 3. Task requires 2. Resources domain implicated. Task costs 10 energy. Agent has 50. Transitions domain implicated. Current status pending. Proposed status authorized. Micro filter phase. Each domain evaluates. Auth 001 checks, is 3 greater than or equal to 2? This is a pass. RES 001 checks, is 10 less than or equal to 50? This is a pass. Rule trans 001 is pending to authorized in a valid graph? If so, pass. The result of this is authorized. This happened because the ontology allowed it. Every rule was satisfied. The system can explain exactly why this outcome occurred. Now, let's fail on purpose. Test 2. Insufficient clearance. The description is an agent with insufficient clearance requests a high security task. Agent Alpha, clearance 3 and resources, requests a task. The macro pull gathers from the same domains. The micro filter sees that 3 is not greater than or equal to 4. This is a fail. The result of this proposal and this orientation is a denial. Here we see the denying rule and the denying reason. The system does not just say no, it says why no. It points to the exact rule that caused denial. This is explicit denial, a core Hypercube guarantee. Now we must introduce frame overlays. These provide contextual modification without mutating base ontology. Emergency mode. Priority 100. Description activated during emergency conditions. Relaxes certain constraints to allow rapid response while maintaining auditability. All actions taken under emergency mode are flagged for post hoc review. When active, emergency mode will modify adjudication. Authorization clearances requirement is reduced by 1. Resource cost tolerance is increased by 20%. Complete tasks can be reopened. This is intended for emergencies, when normal rules simply need to flex. But please take note, we have not changed the ontology. We are overlaying it. Test 3. Emergency mode activation. Emergency mode is now active, and now we will retry the denied proposal. Agent clearance 3, task requires 4. Macro pull now includes active overlays. Micro filter with emergency mode. Auth 001 modified. Effective requirement equals 4 minus 1 equals 3. Agent has 3. 3 is greater than or equal to 3. This passes. The ultimate result is authorized with flags for emergency mode authorization. This is the same proposal, the same base rules with a different outcome. The overlay modified adjudication without touching base ontology. If I remove emergency mode, the proposal is denied again. Ground truth is preserved. This is what separates a frame overlay from mutation. Second overlay, audit mode. Priority 200, higher than emergency mode. Audit mode tightens constraints. Clearance requirement increased by 1. No resource overdraft is permitted. All transactions will require dual authorization. And critically, if both emergency mode and audit mode are active, audit mode wins on conflicts. This is explicit priority ordering. Both overlays are active. Test 4. Audit mode stacking. Priority override. Emergency mode wants to relax clearance. Audit mode wants to tighten it. And now we will see what happens. Macro pull. Both overlays detected. Micro filter. Audit mode priority 200 beats emergency mode priority 100. Rule auth 001 emergency mode says -1. Audit mode says +1. Audit mode wins. Effective requirement equals 4 plus 1 equals 5. The agent has 3. 3 is indeed not greater than or equal to 5. The result, a denial. The system did not guess. The system did not pick randomly. The system followed declared priority rules. Overlay composition is explicit, not emergent. Test 5. The return to ground truth. Here I have removed both overlays. The system returns to base ontology. No residue, no mutation, and no undo required. The overlays sat on top of ontology, never inside it. This is the frame overlay guarantee. Context absent of corruption. Let's recap what we built. 1. Ontology. The declared reality defining entities, properties, states, and transitions. 3. Domains. Orthogonal rule spaces governing authorization, resources, and transitions. They compose without contaminating each other. Two frame overlays. Contextual modifiers that alter adjudication without mutating the base. They stack through explicit priority. They remove cleanly. Macro pull and micro filter. The two-phase resolution mechanism. Gather relevant state, then filter against the rules. Every proposal was authorized or denied explicitly. Every denial included a reason. Every outcome can be traced to a declared rule. This is Hypercube, an ontology-forward, rule-authoritative, state-space adjudication engine. It does not simulate. It does not optimize. It does not guess. It decides what is allowed to happen, and it can always explain why. Thank you very much.